And that way you get 285.
485.
I know, it wouldn't be right. And then you do 360 minus 385.
Hang on a minute.
And that's 75. And then that gives you W. So W equals 35.
So, but to do the directions, it says, find the measures of the exterior angles. What do you have to do before you finish this?
Get right all the exterior angles out.
So answer the question. Okay, do you agree with him?
Yes.
Does anyone not know where this is coming from? Okay, but you're not done until you do the list because that was what it asked for. It asked for the measures of the exterior angles of the polygon. And until you label it, list it out, you haven't answered it. Okay? Because you can do the formula and do all of this, and I can look up there and go, well, they found these, but that doesn't mean that you fully understand what you're being asked still. Okay? So you've got to do, you have to give it the answer. All right? Does that help some of you that didn't do well on your assignment? Thumbs up if yeah, I've got a better understanding, or thumbs down, I don't get it at all, or I'm in between. Okay? All right. Well, with where we're at on the class average, I am going to move on. I've got a couple of you that I have specifically said I want to visit with you during study hall. Miss Madison. On which one, babe? Madison is questioning number 28, so let's check it out. Let's get another one. 28, page 125. Okay. Does anybody have calculator number 13? Take a look, because get a different one, and I will have to go on a calculator war in a little while because they were all there yesterday.
I'll get Ridley's.
Okay, number 28. 28, you have the drawing that looks similar to this. I say similar because this is my crude drawing. Okay. And then it tells me that, I'm not really sure. And 125. Whoops. Go there where I want it. Okay, I know which one this one is. All right. And it asks you to find the measures of the exterior angles of the polygon. Okay? Here's what I know. When I look at this one, I'm just going by what I know about lines and angles. If I look here at this piece right there, are those two pieces together going to create, are these supplementary angles? So I'm looking for a missing supplementary angle. Do you agree? So if I take, and supplementary angles equal 180. So if I take 180 minus 55, will it give me my missing angle here? And what do I get when I do the subtraction there? 180 minus 55. This is an interactive class. I'm giving you something, you interact and give me the answer.
125.
What was that?
125.
125 degrees. Okay, so I've got that one. Can I do the same with this one right here? Go ahead and do that. Edit, undo the cut. Get that out of there. Can I do the same with this piece right there? Okay, so, but my formula is going to be 180 degrees minus 125. What do I get when I do that? Joey? 55. So this one here is 55 degrees. Okay, that gives me two of them. What I could say, and I will, what is the total of the exterior angles? 360 degrees. If I choose this one here to be X, and where's my other? I got another one I gotta find. Oh, up here. Do I have 2X plus 180? Well, that won't work for me because they aren't the same. Okay, that won't work for me. If this one is 55, what does this one know? What's the other interior there? 125. Because these two are the same here. So this one's 125. So then, does that allow me to find the exterior angle out here? Yeah. And it's going to be, what did you just say, Glenn? It's going to be 55 out here. And what's the one up here going to be? If this one's 55 degrees, what is this angle on the interior? 55. So what's my exterior then? 125. Okay, does that help, Madison? On this one here, it was a matter of take a look and see what you know. You don't always have to do the big formula to add it all up and divide. Because if we'd have done that, these two wouldn't have came out right if I'd have given them both X because they're not the same. Okay? Other questions on today's homework? Okay. How do we know if two triangles are similar? Well, what do we mean similar? By definition, what is similar? What'd you say, sir? Alike. Another word for similar would be alike. Okay. The same. You and Chase are similar in that you're both males. You're both in the 8th grade. What's some other similarities that the two of you have? They both have hair. They both play sports. They are both currently wearing tennis shoes. They are similar. But they're not necessarily alike because there are some differences in them. Do you agree? Joey?
They have attributes that are the same.
Good. Good. Big term there. Attributes that are the same. Like it, Joey. Okay, so what are we talking about though? If we're talking about math and geometry, what do we mean if we say two triangles are similar? Yeah, you got it.
Two triangles and one triangle are congruent. Two angles in another triangle, a third angle are also congruent in the triangle.
Okay, now put that in 8th grade English. You got a great math. You see what I mean? Let's get it in English that you understand.
Like 10, like on that one, 10 have 5, and like they're kind of like on the triangle. That the bigger triangle is like obviously bigger than the other one, so like it'd be the same on the other one. I don't know. It's hard to explain.
Okay. Olivia.
You could tell that the smaller one's gonna be half of the size of the bigger one.
The smaller one appears to be half the size. I agree with that. Joey?
The angles won't change with the length and the size of it.
If they're truly similar, their angles are going to be equal or congruent. That was the term that in the official definition used. Congruent. That is true. Madison, did you have anything else you wanted to add? She says they will be proportional. Okay. Similar means, are these two shapes basically the same? They appear to be the same. One's larger than the other. But if they're truly similar, the angles will remain the same. Just because we make it bigger doesn't change the angle of it. And the other term that was used was proportional. we haven't done a lot of talk about dilations in 8th grade this year because they took it out of our standards that I had to teach. But I think you saw last year, 8th graders had pictures where they dilated or they made one picture bigger than another. Okay, you go to how many of you have ever been to the eye doctor? Yeah, that's everybody, right? How many of you have ever had your eyes, they call it dilate? They put drops in your eyes, okay? Why are they dilating your eyes? Do you know?
Look at them better.
To look at them better.
Because everything's the same but bigger.
Yeah, to dilate it is just to make that pupil and all the vessels appear to be bigger. They make them become enlarged so they can see it better. Okay? Okay. We went to the school play that we had several kids in. And Paige, what's her last name? Paige Burley talked about the backdrop. And she brought out a little artist drawing of that backdrop. And it was like on a canvas that was maybe 8.5 by 11, maybe a little bit bigger than that, 15 by 11 or something. But she said that the backdrop was proportional to her drawing. So she took what she drew and she enlarged it to make it similar, but yet it was different because it was bigger. That's similar, okay? But it had to be done proportionally or it wouldn't have looked the same. Your photographs that you get every year, we go down here and we take pictures, and your parents order the pictures. And some of the pictures are 8 by 10, and some of them may be that little bitty, I don't know, wallet size, and some of them are even 1.5 inches by about 2 inches. It's those ones that you exchange them with your friends and they're a lot smaller. If those pictures were not done proportionally, you would look very distorted. How many of you, I know you have, the filters on your phones, and you make them bigger, and maybe you stretch it out where you got this long, okay?
Long.
They're no longer similar because they're not proportional, okay? When you stand in front of that mirror at the fun house, yeah. And your legs look like they're this long, and your body looks like it's this long. It's not similar because it's not proportional. Does that make sense? So, in order to figure out if they're proportional or if they're similar, we've got to know that they are proportional. How am I going to do that? Well, I didn't freeze it, I know. Can I set up this side to this side? I'm going to compare two things. A proportion is a comparison between two things. Do you agree?
Yeah.
So I'm going to compare 4/10, and I'm going to compare that to x over 5. Now, this says they're similar. So if they are similar, then I can find the value of x. They've told us they're similar. And all I have to do is solve for x. In this one, Joey, how would I do that?
Well, it's hidden 5, so you would times 5 by 2 to make it 10, and then you do the same to the top.
Okay, so you could look at that and just knowing the numbers, you could say 5 is half of 10, half of 4 would be 2. Okay, I agree. Which would tell me that this piece would be 2. Totally agree with that. That is one method or one way to do it. If you know your numbers and they just pop out at you like that. They don't always pop out as like that though. Ty?
You could do 5 times 4 and then divide it by 10.
Good. You could do the cross product where you could say 4 times 5. Whoops, I don't want to use that symbol. 4 times 5 equals 10x. And then you'd have to solve for the x, and x would be equal to 2. Because 4 times 5 is 20, divided by 10 is 2. So that, 2 different ways of doing it. Both ways are effective. Okay? So I've given you that one. You figure it out. You tell me, what is the value of x in number 2? what is the value of x in number 2? When you're taking the notes, it's really a good idea that you write or you get down in your notes these formulas, these methods. Because if all you do is write the answer to that value of x, you have no idea where it came from, and when you go back to study it or to get help from your notes, it's not there.
Why is there two?
One isn't equal.
It's just because that's what the answer was, that's what X is. Yeah, it'd be 9. This one's longer than this side. 12 on this side is the same size as this side.
I've heard 9 like 3 times.
That's how I would have said it, but shoot. And that's something I have talked about.
6.
Yeah.
60.
What?
Okay, one of the things that I didn't bring out. These two shapes are similar, they tell us they're similar. If I don't compare the same side to the same side on both, it's not gonna give me a correct answer. If I would have flipped these, and instead of saying, if this one I said was 4 to 10, and I said this one was 5 to 2, I wouldn't have came up with the same answer. Okay? So you have to be careful, and you have to know what part of the triangle X is. This is not an equilateral triangle. All sides are not the same, right? So I have to compare the same side to the same side. If I look at this shape, what do we call X? If we was to identify the pieces of that triangle, what do we call the part of the triangle that is the longest piece? What do we call that piece? The hypotenuse, right. And so this X is definitely the hypotenuse. This is a leg, and this other one is a leg. So the question is, where's the hypotenuse on the smaller triangle? What's the hypotenuse on the smaller triangle? What is it there, Dakota? What do you think? What's the measure of the hypotenuse on the smaller triangle? Okay, honestly, it's not 9. What's the measure of the hypotenuse on the smaller triangle? Marissa? 12. So if I compare hypotenuse to hypotenuse, then I can compare the base to the base. And the base here is 12, and the base here is
How do you know
9.
which one? Like above. How do you know which one to put the numerator and which one to?
It's not gonna matter. I could say hypotenuse to base, like I have here, or I could say base to base and hypotenuse to hypotenuse, as long as I put them across from each other.
Like based on how far along.
Hypotenuse.
Hypotenuse on top of that.
Hypotenuse. Hidden hypotenuse.
We gotta go too, don't we? All right, ladies and gentlemen, guess what?
What?
Bring the notes, no assignment.
You're so awesome.